we've talked about Jupiter and we talked about Saturn and we talked about the moons of those worlds. But we're going to talk now about Uranus. Now, since ancient times, people have looked up in the sky and they've seen stars, and they saw some of the stars that looked like they moved. Those are the planets, the classical planets, Mercury and Venus, Mars, Jupiter, and Saturn. Later, when Galileo was investigating, and then prior to him, Tycho, they realized that Earth goes around the sun too. And they gradually came to the realization that Earth is a planet because planets are things that go around the sun. And so that meant the planets of the solar system were Mercury, Venus, Earth, Mars, Jupiter, and Saturn. For a while, they considered the moon a planet. They considered, because it also goes around in the sky and so forth. Then they realized, well, no, we're not going to call that a planet. We're going to call it a moon. But that's all that they knew. They had not yet discovered asteroids. They had not yet discovered the moons around the other worlds. And then we talked about the story of William Herschel early in the semester. We talked about how William Herschel was originally trained as a musician. He was actually German and moved to England, changed his name to William Herschel to make it sound more English. And as he and his sister Carolyn were studying the sky, he noticed this thing that was kind of a little fuzzy and moved around the sky. He originally records it as a comet to a star. He thought he discovered a comet, in fact. And then after studying it for a while, he began to realize that it was a planet. And of course, he's the one that named it George. The name George never stuck. But still, he got famous for this. But that was the discovery of Uranus, and that was in March of 1781. In the telescope from Earth, Uranus really looks boring. It looks like a very small, completely featureless, greenish, bluish ball. It's a long ways from the sun, so it's not very bright. It's right at the threshold of naked eye visibility. In theory, when we're near conjunction, when we're near opposition, when it's brightest in the sky, then it's technically visible to the naked eye, barely, if you've got really good eyes and a really dark location, and it's really high in the sky. But it'd be just barely visible, like all the stars that are barely visible, and would just totally be lost in all the other things that are up there. That's about it. That's about all we knew about it. We knew it goes around the sun. We knew it went around the sun pretty slowly because it's so fast. Over time, they were able to figure out the size of it once they figured out the distance. In size, it's about 4 Earth diameters. Now, that means that you could fit about 60-something Earths inside of it because it is big enough. You know, it's not just 4 times across, it's 4 times across one way, 4 times across the other way, and then 4, so in 3 dimensions there. So 4 Earth diameters generally means about 64 Earths would fit inside of it. It rotates, we now know, in about 17¼ hours. Because it's 19 AU from the sun, it takes about 84 years to orbit. And so in those 84 years of orbiting, that's a long time. So it takes a long time to watch the thing go through one complete cycle. So for most of your life, it's going to be in a new constellation here all the time. Okay, it takes a very long time, roughly here, roughly it would take about 7 years, 6 or 7 years to go through a constellation. So it's going to be several years going through each constellation in the sky. We now know it's got about 27 moons. Okay, it's probably got more than that, but it's a long ways away and very difficult to observe. By observing those moons, we are able to figure out the mass of it. It's got between 14 and 15 times the mass of the Earth. Albedo is 0.56. Albedo is how much light it reflects. So it reflects 56% of the light that hits it. The composition is mostly hydrogen and helium. Now, that's the atmosphere. That's the part that we see. When we look at it, it's mostly hydrogen and helium. Because this is a giant world, and it has hydrogen and helium as a main constituent of it, it's generally regarded as a gas giant. It was very obvious that Jupiter and Saturn are mostly hydrogen and helium. The hydrogen and helium make up the bulk of those worlds, and they are gas giants. The assumption was that Uranus and Neptune are smaller versions of that, that they are also gas giants. Now, we're going to find out that assumption is actually slightly wrong. The atmosphere is hydrogen and helium, just like Jupiter and Saturn's atmosphere, but these worlds also contain a large portion of other things inside of them, unlike Saturn and Jupiter, which are still mostly hydrogen and helium. Careful observations over the years indicated that it's tilted about 98 degrees. In other words, it's almost on its side as it goes around the sun. So as it goes around the sun, it spends like 21 years in spring and 21 years in the fall, 21 years, for summer and 21 years for winter. And so very, very long seasons on this thing. So these are kind of the things that we know about it from observing it from far away. Thing is, to really observe it, we need to get up close to observe it. Just to finish up what we were saying before, seasons on Uranus, the last winter solstice, that's when the northern hemisphere was pointed away from the sun, so the south pole pointing towards the sun, so this is like northern hemisphere part, was in 1986. The vernal equinox, so springtime on Uranus, was in 2007. Summer solstice, in other words, the North Pole pointed directly towards the sun, or closest directly towards the sun, is going to be in 2028 coming up here. And then the autumnal equinox is going to be in 2049. And the next complete cycle is going to be in 2070. Now, as I said, to really get a good look at it, you got to go there. And so the Voyager spacecraft, remember this was going to be the grand tour. The Voyager spacecraft was going to launch from Earth and then slingshot past Jupiter and Saturn, Uranus, and Neptune. Voyager 1 was sacrificed when it went past Saturn. They decided to sacrifice it so that instead of slinging to Uranus and then to Neptune, it instead was set so that it would sling and cross the rings of Saturn, and that way we would get the best view of the rings. This is before they realized there's rings on everything, and so, but they really wanted to study the rings of Saturn, and they thought, well, we'll go ahead and sacrifice it and then send Voyager 2 on to the others. At the time, they thought it would be more important to make sure we got the rings studied than the outer planets. So Voyager 2, which came afterwards, it arrived about a year after the Voyager 1 did at Saturn, and let Saturn slingshot it on to Uranus. So it arrived in January of 1986. Now remember, that's real close to when the South Pole was pointed at the sun. And so we knew that this was going to be kind of unfortunate that we don't get to see it on the side, but we'd get to see, something. Well, every other world we'd looked at was spectacular. And so we were all excited to see our first view here. And I'll address that in the very next lecture.